All right, good morning. Horticulture 164, Hort Pest Management. This is a PowerPoint presentation on calibration without math. As you guys know from the last PowerPoint that we saw, included a lot of math. Kind of got everybody a little confused. So we're going to step back and we're going to do some calibration without math. My name's Eric Jones. Today's date is June the 11th, Monday morning, 8 o'clock. And I'm glad you guys are here. All right, introduction. Can you calibrate a sprayer or spreader without using math?
Yes. Yeah.
Yes, you think you can?
Yeah, the way it says in a book, you can.
Okay. And based on the title of the presentation, you should be able to, right? This isn't a short PowerPoint. Was it 61, 62 pages?
Yeah,
63 pages. All right.
There's one that said 80.
That's why there's 6 to a page.
All right, but ladies and gentlemen, let's view this. We're going to write down some key terms. The PowerPoint's online, so I'm recording it right now as well, and you'll see the presentation online. That'll be put all on Blackboard for you. All right, to find out, let's see exactly what the definition of calibration is. That's a good old lengthy definition. I used Webster's dictionary, so we're gonna look it up. All right, according to Webster's dictionary, calibration is defined as to determine, check, or rectify the gradation of any instrument given quantitative measurements. Man, that sounds like chemistry class, don't it, instead of pest management? Or to standardize as a measuring instrument by determining the deviation from a standard so as to ascertain the proper correction factors. So when you guys come in next Monday, I'm going to say, Jerry, what's the definition of calibration? Jabir, what does that mean? Means get out your book or notes, right? All right, but that is the definition according to Webster's.
Well, you said this is online, though, right?
It's all online, yeah.
So, I mean, yeah, okay. I'll get that later.
But write down this real quick. And I know you guys can write messy and quick because that's how the worksheets look.
Hey, now my worksheets are.
Oh no, yeah. Miranda's looks like it comes out of a printer.
That's right.
It's the females that write really well and professional.
Yeah, I appreciate that.
Yeah, but they've been practicing since elementary school. Yeah, them love those.
All right, you guys ready? Can we move on?
Let's do it. Come on, messy.
Hey, if I write messy, I will never forgive myself.
Messy and quick.
Because then I will not be able to read it, so therefore all the writing was pointless.
Quit talking and keep writing.
I don't want to take the time to
She is actually doing both.
and him talk.
According to Webster's dictionary, calibration is defined as, all right, to adjust precisely for a particular function and to measure precisely, especially to measure against a standard. A little bit shorter, easier to remember.
That makes sense, too.
That makes sense. So knowing this, is it feasible to have calibration without math? Can I get a yes or no?
Yes.
Huh?
Yes.
No.
You think?
I say no.
You say no?
No,
You gotta have the right measurements.
absolutely not.
Absolutely not, huh?
I'm going to say no because using
Lessons all laid out there for you.
well, using the math makes it more simpler.
I don't know about that.
Well,
And you can see the math problem on the board. That's acres squared.
versus walking it off all the time.
This is how you figure out how much pesticides put out. Area squared times chemical to the cube divided by my age. I'm 39. That's how long it'll take. I'm just kidding. That's just a picture of math.
But you said in here,
Absolutely not.
So knowing this, is it feasible? Absolutely not. We got to have a little bit of math, just a little bit. And y'all gonna learn it from the old Eric Jones way. However, there are several ways to calibrate, some of which involve much less math than others. We got some real simple ways to calculate this stuff, guys. Fun ways. You'll want to work these problems. You get bored at home and you'll be pulling out your pesticide books and reworking these. That's what I do in my spare time. I read chemical labels. Yeah. I get bored. Download them on the iPad and sit there and read. Oh man, this can take care of that. All right, with that being said, the title of this lecture should be what?
Without much math.
Calibration without much math. Because we do have a little bit.
Without less.
That should be a test question. What was that?
All right, I like to break calibration down into two methods. One is traditional, the other is alternative. Sounds like music, don't it? They're both good ways, and we're going to see each method for granular application, spray application. You'll see it. So we'll see 4 different ways, 2 for each. And then you guys can tell me which is your favorite. All right, your traditional method of calibration. The advantages. There are some advantages. It's the most precise. It's recommended for fine turf applications such as putting greens, golf courses. And it's recommended when applying expensive products due to cost control. An example is Heritage. Has anybody looked up Heritage in their chemicals book?
oh,
It's a fungicide.
yeah.
Mucho dinero, but it works good.
What is it, 90 bucks or no?
There's more than that. But definitely, it's the best way to go if you have the time, manpower, and expertise to do so. Time is money. We got all the time in the world, right? Not. We're all going to school. We're all working, studying. We live on Blackboard.
Got kids.
Got kids.
They keep on coming to and playing the blackboard. Get away.
All right, the Heritage fungicide. Hey, a 4-ounce bottle around 125 bucks.
But it comes in a bag too.
You can get it in a bag, but this 4-ounce bottle, 125. I looked up some prices online and found it, but the stuff works. It's awesome. It's awesome.
Said that the water number.
That's in real life going to be a small bottle.
Yeah, that's tiny. It's like a Tylenol bottle, ain't it? All right, some disadvantages of the traditional method. Time consuming. It's math oriented. Can be overkill in certain settings. And it can be hard to relay down the chain of command. It might be hard to tell your employee that's not used to it or haven't been to the certified applicators test or training or taken my class. There's a few laughs. You were supposed to laugh at that. All right, your alternative method of calibration. There's some advantage to that. It's easy to comprehend and relay to your employees, so you can explain it to them. Good for quick and easy determination in the field. You know, you don't have that calculator or notepad. You always have them when you don't need them, and when you need a piece of paper and a pen, you can never find one in the truck. It will get you very close without cumbersome math, and in many situations is more than adequate to meet turf grass needs. So going out and doing a lawn here in Winston-Salem, yeah, would do this alternative method. If we were on a golf course, you know, Old Town Club or Forsyth Country Club, we wouldn't do this. All right, some disadvantages to your alternative method. Not recommended for use on fine turf greens. Any type of golf courses or anything like that, you would not want to use it. It's also not recommended when using products that are likely to damage turf from improper application rates. You may get just 1 ounce too much and it's going to burn your turf. It could kill your turf. And it's not recommended for expensive products due to cost control. Yeah, if you're buying some $300 a gallon chemical, you want to get it precise. And you want to put that chemical back on the shelf and save it for the next time instead of wasting it. Because if you have some left over, you can always apply it to your own home. Not, my yard's got the most weeds of anybody. All right, and no matter which approach you use, calibration will have to be broken down into 2 further categories. The 2 categories are calibration of equipment that applies granular products. These are your fertilizer spreaders. Your tractor, you got the push spreader here as seen in the slide, and you also got the rear mount 3-point hookups for little lawn tractors.
We got the big ones for big trucks.
And then you have the big fertilizer trucks that come out and do fields, agricultural, which we won't get into that. All right, the next one is calibration of equipment that applies liquid products. That's a good little lawn tractor there. It's got the sprayer on it. You wouldn't want to take this in somebody's yard, but this is, you'd want to use this like on football fields, golf course greens, whatever.
I don't like John Deere, they're just 2 of them price.
Oh, I'm just talking about the setup and the size. That's good around farms and stuff like that too. All right, granular products. The most common product applied in granular form is what? Fertilizer. And then you can see there's the little ratios, your NPK. Anybody tell me what that means? And we'll get into that a little bit later too, but what's your N stand for? Nitrogen. All right, what's your P stand for? And what's your K? Potassium. So there we have a picture of a 21-3-20. And usually in our calculations, guys, what we're more concerned about in the lawn care industry is 1 pound of nitrogen per 1,000 square feet. So that's really the only math we're going to do in this presentation.
So 1 pound of nitrogen per?
1 pound of nitrogen per 1,000 square feet of turf. 1 to 1,000. All right, 2 things you need to know to apply the proper amount of fertilizer is your square footage or acreage of the area being fertilized and the analysis of the product being applied. That analysis is going to be on the fertilized bag. You know that 2138 cartoon picture of that fertilized bag? That's your analysis. And your square footage is when you go out and you're estimating how much it'll fertilize this yard. You give the customer a quote, hey, I can fertilize this yard for 50, 60 bucks. You know, you're getting your square footage. This is true for both traditional as well as alternative methods. You need to know square footage and you need to know your product analysis. Example, let's say you want to apply complete fertilizer 2 weeks after a spring green up on a Bermuda grass football field. First of all, what's spring green up? We're talking about Bermuda grass. What does Bermuda do in the late fall and through the winter? It goes dormant. It's not dead, but it goes dormant, turns brown. That's why a lot of people don't like it in this area. It doesn't bother me. That's what I'm saying. If you've got Bermuda in your lawn, why not let it take over and make it the best standing grass in your lawn? We're in that transition period, transition zone, where we could have warm season grasses or cool season grasses. You know, and I love warm season grasses, but I also love bluegrass. You know, so I mean, it's you know, be nice to have a little bit of both, but you know, Bermuda grass, you know, there's nothing wrong with it. People hate it, but Yeah, it can be pretty. It can be real pretty.
I understand, yeah, it does.
All right, on this football field, how much fertilizer do you need to buy if you're applying what? 1 pound of nitrogen per 1,000 square feet using a product with an analysis of 28,512. So how much product?
50-pound bag?
Huh?
50-pound bag?
Typically, all fertilized products will come in a 50-pound bag.
About 2,000-pound bag.
I'm not going to pick it up because I'm going to send one. I'm going to send one guy out in a pickup truck with a fertilizer spreader. Now that that's a pallet because they put 40 bags on a pallet.
Yeah, but you can buy it now in big sacks now.
Big, yeah.
2,000 pounds in there.
Yeah, that's farm use.
Buy coat or whatever they call it. Like.
But I definitely wouldn't buy that for lawn care. But
How
yeah,
many yards you got to do?
just depends, man. It's all about ease and making it easier on your guys. And
About $200 a ton, something like that.
well, you got to look at storage facilities.
You go in the truck and use it all the week. You don't need nothing.
I'm not going to get up in the back of the truck and shovel it in my fertilizer spreader. No. All right, but using the traditional method on this, step one, we got to measure the football field. Does anybody know right offhand how many square foot's in a football field?
How big a wide is?
100 yard, what is it?
60 yards wide, 100 yards long.
It's definitely 100 yards long.
Yeah.
I'm thinking it's 60 wide.
60 by 100.
And you can do this by stepping it off, using a tape measure, or shooting it with a transit. Or if a customer calls you and asks this is information we can find online. What's the square footage of a football field? They're all in regulation. They're all going to be the same size. All right, we have done this and we have come up with the square footage of 90,000 square feet for this football field. A lot of turf. All right, step two, we're going to calculate how many pounds of nitrogen you need to apply to achieve the desired rate. A proportional method. If this, then what? All right, so we're setting up our formula. We've got 1 pound of nitrogen over 1,000 square feet. Remember that. We're always worried about a pound of nitrogen per 1,000 square feet. So that is your first fraction. And that is equal to X, meaning what we're solving for. So how many pounds of nitrogen for that 90,000 square feet? So 1 pound of nitrogen over 1,000 square feet is equal to how many pounds of nitrogen per 90,000 square feet? So what are we going to do in this problem?
Cross multiply.
We're going to cross multiply. So we're going to multiply 1 pound of nitrogen times 90,000 square feet. And that's going to be equivalent to X times 1,000 square feet. So we have 1 pound of nitrogen times 90,000 is equal to X amount of pounds of nitrogen times 1,000 square feet. So that's going to be, I didn't work down the problem any further, but 90,000 is equal to 1,000. Divide 90,000 by 1,000. So X is solved for 90 pounds of nitrogen. That's how many pounds of nitrogen we need to put on the football field at 1 pound per 1,000 square feet. All right, step three, you're going to calculate how many pounds of this 28,512 fertilizer you need to get the 90 pounds of nitrogen. And that's the last part of the math for this problem. Well, again, it's just cross multiplication. All right, the 0.28. Where are we getting that 0.28 pounds of nitrogen? It's the first number out of our ratio, our analysis. So 0.28 pounds of nitrogen over 1 pound of fertilizer is equal to 90 pounds nitrogen, and we're trying to solve for X here, pounds of fertilizer. So when we do a cross multiplication, 0.28 times X, oops, sorry. So 0.28 times X is equivalent to 90 pounds times 1 pound. And y'all know what this is going to be. It's basically 90 pounds divided by 0.28. I'm not sure if you can see that little bit at the bottom. I might have to pull the screen down. And X is equal to 321 pounds of fertilizer. And if you're Jerry, that's got that big bag in his truck, he's going to be shoveling for a little bit.
320 pounds, you won't be shoveling much. That ain't much. That ain't one good hopper full.
And how many bags do you think this is, guys, of 50-pound bags?
7.
All right, now we're trying to figure out how many pounds we got it. We've got 321 pounds of fertilizer divided by 50-pound bags. So we've got 6.4 bags of 28,512 to apply 1 pound of nitrogen to this football field of 90,000 square feet. All right, traditional method 2. All right, it's the same thing. Step 1, measure the football field. Can be done stepping it off using a tape measure or shooting it with a transit. And you have done this using one of the methods and found your area to be 90,000 square feet. So this is a repeat, guys. We're doing another method, another way within the traditional. And we can plug in the information into the following equation, stoichiometry method. Don't pay attention to that. That's a chemistry term. But area times rate times analysis. Area, 90,000 square feet. Rate times analysis. All right, here's this equation. Area times rate times analysis. 90,000 square feet times 1 pound of nitrogen per 1,000 square feet times 1 pound of fertilizer per 0.28 pounds of nitrogen gives us the same answer of 321 pounds of fertilizer, which is equivalent to 6 4-point bags of your 28,512. Just a different way, just a different math formula to get the same answer on your traditional method.
It's really like the same formula we put number 1.
All right, your alternative method. It's also called your common sense approach. Step 1, measure the football field. Hey, we've done this. We've come up with 90,000 square feet. The same thing. This method, though, will only work when applying a rate of 1 pound per nutrient per 1,000 square foot. So, the traditional method, like I said, we could figure out 2 pounds per 1,000. We could figure out 1 pound per 2,000 square feet. We could substitute any of that rate for there. But this one, we can only do it 1 per 1,000. All right, step 2. Most fertilizer products come in the 50-pound bags. We already know that. Divide the first number in the fertilizer analysis by 2. What's the first number?
14.
Yeah, it's your nitrogen analysis. All right, this number represents how many pounds of nitrogen are in the bag and thus how many square feet this bag will cover. So 28 divided by 2 is equal to 14 pounds of nitrogen or 14,000 square feet. We've got 14 pounds of nitrogen. We're putting out 1 per 1,000. So we know that that 50-pound bag of 28,512 will do a 14,000 square foot lawn. Step 3, we're going to divide the total square footage by the square footage on the bag. So 90,000 square feet in our football field divided by 14,000 square foot per bag is going to give us our total number of bags of 6.4. All right, here's a review from your alternative method. 28 by 2 is 14 pounds of nitrogen or 14,000 square feet. Just a couple of slides ago. And 90,000 square feet divided by 14,000 square feet gives us the 6.4 bag of 28,512. Even though this is still 2 steps, it is a much more common sense and intuitive approach, especially to those who despise algebra. We're not doing any much cross multiplying. So what is it? Area times what? Times what? All right. And instead of proportions or stoichiometry, or however you say that long word, it's only 2 divisions. All right, the alternative method. This method is particularly useful for small areas that you will find in the lawn care industry. The average home in Raleigh is what? 5,000 square feet. You know, postage stamp lots, guys. And for small lawns like this, it's actually just 1 division. You don't even need a calculator. So, we're still using our 28,512 50-pound bag. We know it's going to cover 14,000 square feet. And you'll see that on the actual analysis sheet. Usually it's just a piece of paper printed off a computer and they've glued it to the bag. It'll have your analysis and it'll say this bag will cover X amount of square feet. So we've got a 5,000 square foot lawn in these neighborhoods. Say we're in a neighborhood with 100 homes and each one of them's averaging 5,000 square feet. Well, we know that 1/3 of the bag, because 1/3 of 14,000 is roughly 5. You know, I'm not going to get to the T. When we go in a neighborhood like that that's got those postage stamp lots, some might be 6,000, some might be 5,000, some might be 5,500. They're all going to be priced the same. You know, it's going to be X amount of dollars to do this house, just like the neighbor down the street. Why? Because neighbors talk, and if you're charging $5 more, you know, you'll lose that customer. So it's worth it just to figure it all on an average for these size homes. Now, if you go into somewhere like Bentry, where somebody might have a 2-acre lawn and the next door neighbor's got an acre lawn, you're not going to give them the same price. Liquid products. There are many products that are best applied in liquid as opposed to granular form. You're going to want to put out fungicides in a liquid form, some herbicides, some insecticides, and then if you're spoon feeding, liquid fertilizers. And there's many more. There are some granular fungicides. They're a lot easier to put out. Just wear a mask and all that crap. You've got to get all that stuff out because those are very dusty. And as with granular calibration, there is traditional as well as an alternative method when approaching your sprayer calibration. And these 2 methods are the traditional 5940 and the alternative, the 1/128th acre method. All right, let's go ahead and we'll start with the traditional method. The 5940 method, where we have our gallons per acre, and our gallons per acre is equal to gallons per minute times our constant of 5940 divided by our miles per hour times our nozzle spacing in inches. Or we can calculate this method using the gallons per minute math problem, which is gallons per acre times miles per hour times nozzle spacing in inches divided by 5940. And here we know that GPM is equal to gallons per minute, GPA is gallons per acre, NSI is your nozzle spacing in inches, and 5940 is a constant. All right. And here we're going to discuss the alternative method of the 1/128th acre method. It requires the same equipment as the 5940, but only requires 1 math step. So you guys will probably like this step probably a whole lot better. All right, some equipment that you're going to need. You're going to need a stopwatch. You're going to need something to catch water in, graduated cylinder, or I like using the measuring cans that we use to measure our pesticides in. You're going to need a tape measure, and you're going to need flags, spray paint, some traffic cones or whatever to mark your course. All right, the 1/128th acre method. First thing you're going to do, you're going to check the nozzles for evenness. Are they all spraying the same? Is one spraying flat? Is one going off in one direction? They all need to be consistent. They need to have the same spray pattern. Number two, measure that nozzle spacing in feet. Take a tape measure, measure the distance. If you come up with 24 inches, it's 2 feet. If you come up with 18 inches, it's a foot and a half. We're measuring it in feet. Step three, divide 340 by the nozzle spacing in feet. So if we did have 18 inches, which is a 1.5, we're going to divide 1.5 into 340. Step four, we're going to measure out the distance from step three. So whatever we get from step three, that's going to be our distance on our course. Step five, we're going to drive that distance forward at spraying speed and record the time. 6, you're going to catch one nozzle for time in step 5. And then step 7, the ounces caught is your gallons per acre. So whatever from step 6, what you catch and that nozzle is your ounces caught in step 7. When doing the 1/128th acre method, there's 4 things that's going to have to remain constant, and that's going to be your sprayer speed, your boom pressure, your nozzle volume, and your viscosity of your material, the thickness. Sprayer speed, you guys have got to go the exact same speed. Boom pressure, check your gauges, make sure your PSI, everything's good to go on your pumps. Your nozzle volume and your viscosity. You need to have your material what we like to call agitated. If you've got material in there, if we're just calibrating with water, that's fine. But sometimes, and you'll see in applying pesticides correctly, unit 10, sometimes you need to calibrate with the exact chemical that you're going to be using. So everything needs to be the same thickness. You don't need to have your pesticide settle out at the bottom and water up top. It all needs to be mixed in together. Your sprayer speed and boom pressure can both be held constant by monitoring the gauges on your sprayer. Just keep an eye on them. Nozzle volume can be held constant by always using similar nozzles. Viscosity is almost always consistent. Term there, almost. There's going to be times that it's not. All right, going back to step 1, check nozzles for evenness. If nozzles are not evenly distributing, they may need to be cleaned or replaced. There can be a lot of trash that gets in those little nozzles. Depending on what type, if you're running well water or whatever, sometimes just a little buildup. If you're, could be some sand in it or whatever, you need to check it. Make sure they're cleaned out. Step 2, you're going to measure nozzle spacing in feet. Let's say that the nozzle spacing in the previous picture is 1.7 feet. A little over 1.5 feet. All right, step 3, we're going to divide 340 by the nozzle spacing in feet. This gives us 340 divided by 1.7, which gives us 200 feet. This is the only step that you guys need to perform any math. This is going to be the length of our course too, 200 feet. All right, measure out the distance from step 3. We have our 200 feet. There we are, just measuring 200 feet straight out. That's going to be the course that we're going to drive our sprayer. Step 5, drive that distance forward at spraying speed and record time. All right, example, taking 34 seconds to travel the 200 feet course is equivalent to 4 miles per hour. Step 6, catch one nozzle for the time it took to travel the 200 feet from step 5. Example, catching water for 34 seconds using a 8004 nozzle at 40 psi yields 29 ounces. Step 7, ounces that you catch is equal to your gallons per acre. 29 ounces caught is equal to 29 gallons per acre. The good thing about this method is that if you decide to change nozzles, all you need to do is catch the water for the new nozzle in the same amount of time. Easy enough. You don't have to do anything else with your sprayer. Just change the nozzles and catch it for the new nozzles. All right, after this point, the rest of the work is the same as the 5940 equation. If you are applying 29 gallons per acre and have a 150 gallon tank, you can spray 5.1 acres per tank. We have our 150 gallon tank divided by our 29 gallons per acre is going to give us a total of 5.1 acres. A product such as 2,4-D that is applied at 3 quarts per acre means you need to put 15.3 quarts of 2,4-D per tank. 3 quarts per acre times 5.5 acres, 5.1 acres is equal to 15.3 quarts of 2,4-D. 2,4-D is a chemical that's found in a lot of your broadleaf weed killers. It's been around for years. It's the active ingredient in a lot of broadleaf weed killers. Questions, comments, or concerns? References. I like to give reference to Casey Reynolds. He is a North Carolina State turfgrass research technician, and he's a certified turfgrass professional, and Dr. Grady Miller, NC State turfgrass professor. A lot of this information was coming off PowerPoints, pamphlets, brochures, and stuff that I had gotten from continuing education classes from these gentlemen. So I'd like to thank them.